and a polynomial of length 3, the sum is going to be of length 3. Poly sum dot n equals to n, and we're going to keep the min to no. Actually, we have to do a bit of stuff here. We'll basically have to duplicate the whole thing because it's pretty different depending on sum.n equals p2.n then sum.coeffs be the same thing. Here, there. Okay. For I equals 0, I smaller than sum.n, no, I smaller than p1.n, I plus plus, sum coeffs I equals p1 coeffs y plus p2 coeffs y. And then for I equals to p1.n, I less than sum.n, right? So when you have two polynomials of unequal length, you add each coefficient when both of them are defined. When only one of them is defined, it means the other one is equal to 0. And so you just add the one that's defined. Same thing. Except it's different for this because now P2 is the minimum. We still do this and then P2. So we see that we have some pretty repetitive thing going on there. There would be ways to not have that repeated, but let's not bother about that for now. Let's forget about that. Sum. Return sum. Let's try to add P to itself. Let's try P equals add poly P. Alright, so we've doubled the polynomial. Let's try we can also multiply by a constant poly so double poly P. If we do these things, we will get a polynomial. It's pretty straightforward in this case. Poly result dot n equals p dot n, and the result dot coefs double malloc. And for pretty straightforward. Right. Constant do we multiply two polynomials, right? That's a bit trickier. Poly P1, poly P2. So to see what I'm going to do, if you have you know, A, B, C, D as coefficients, multiplying E, F, G, H. All right, you got, or say EFG or EF. So this is a polynomial of degree 3. This is a linear function. How do you multiply them? Well, you know that the size is going to give you the biggest thing you're going to get will be F times D. So this is constant, this is proportional to x, it's proportional to x cubed, so you'll get up until x to the fourth, I mean. So you're going to get 5 things, right? The best way to see what's going on is to say if the degree, because the most significant power, biggest power, is going to be the sum of the most significant power in each polynomial. So the degree of P1 plus degree of P2. Degree just means the number in the power. It's going to be the sum. The degree of the product will be the sum of the degrees of the inputs. So the degree is going to be n minus 1 plus n minus 1, and that's going to be n minus 1. So here you have a minus 2, here you have a minus 1, so n is going to be, for this thing, n is going to be n for this thing plus n for this thing minus 1.